Okay, so we're learning to compare two linear functions represented in different ways. So we're going to find and compare the slopes for the linear functions f and g. This is f, this is g, okay? Because they're represented in different ways. One we have an equation, one we have a table of data. So f is already written in slope-intercept form. We can write y equals mx plus b above it, or f of x equals mx plus b, because that's what we're supposed to be looking at. So the m is 10 because it's the coefficient of the x. So the slope of m of f is 10 because the slope of f, you can just cross that out. The slope of f is 10. Okay, this is f. And we know the slope is 10 because it's always the coefficient of the x. Okay, now we need to find the slope of g, and we need to use the slope formula, and remember that is y2 minus y1 over x2 minus x1. Okay, so we can choose any 2 points on our table of data. Okay, let's choose this one and this one just because then we don't have to deal with negatives. Makes it a little bit easier. So remember, this is your x, this is your y. So y2, we would have 15 minus 10 over x2, which is 1, minus 0. 15 minus 10 is 5. 1 minus 0 is 1. So 5 divided by 1 equals 5. So the slope of g is 5. So when we compare those, the slope of f is 5 greater than the slope of g. Would you agree? 10 is 5 greater than 5? Or you could have the slope of f is twice that than the slope of g or something. You just have to give an explanation. Find and compare the y-intercepts for the linear functions f and g. So this is f, this is g. They're in different representations because that's what we're learning. So neither one of them is written in y equals mx plus b form, so we have to do a little bit of work. Okay? However, if you remember, where x is 0, that is the y-intercept, right? So on f, we see that x is 0, where y is negative 6. So the y-intercept is negative 6. Okay? Now we have to look at the graph. And we can see that the graph crosses the y-intercept. Where x is 0, y is negative 5. So the y-intercept of g is negative 5. So the y-intercept of g is 1 more than the y-intercept of f. Okay, because g is 1 greater, because negative 5 is 1 greater than negative 6. Fred and Jean are hang gliding. Those are probably old men. Fred is 700 feet above the ground and descending at 15 feet per second. Jean is descending as shown in the table. Interpret the rates of change and initial values of linear functions in terms of the situations they model. Alright, that sounds simple enough. So Fred is descending 15 feet per second. That's where they get the negative 15. The x is the number of seconds. Okay, and he was 700 feet above the ground to begin with. So if you were to graph that, it might look something like this. 700 feet above the ground, and he's descending. He's getting, this is the ground. He's getting closer to the ground. Okay, so we have a negative slope. Jean is descending as shown in the table. He started at 575 feet because that's when he had not hang glided at all, okay? And it looks as if he is descending 10 feet per second because each second we gain, it subtracts 10 feet in height. So we can say f of x equals negative 10x because he's descending plus 575 because that's where he started at, okay? So, Fred, we need to find Fred's rate of change, which is the m. The slope and the rate of change are the same thing. Well, now that we have an equation for each of them, it's pretty easy because we can look at this and say, well, Fred's rate of change is negative 15 because negative 15 is the coefficient of x, and that is our slope or our rate of change. So negative 15. And our initial value for Fred, we said he started at 700 feet. Okay? Now the same thing for Gene. The rate of change, we already know, looking at the heights, that he was decreasing by 10 feet each time. And we know that the initial value was where the time was 0, so his initial value is 575. But let's say you couldn't figure out the pattern of 575, 565, 555. You would have to find the slope, and you would have to take y2 minus y1 over x2 minus x1. So remember, we would take two values. Y2, we'd have 565 minus 575 over 1 minus 0. I don't know why I didn't use my little box. And then we get negative 10 over 1, which is negative 10. So some of them are very easy to be able to tell the pattern, some are not. Find and compare the slopes and y-intercepts of the linear functions f and g. This is f, this is g.